second chapter in your party, that is inverse trigonometric functions. So in this you can expect 8 mark in your main exam, that is 1 mark 1 question, 2 mark 2 questions and a 3 mark 1 question, and this is for 8 mark. Okay, from this chapter you can expect a 8 mark in your main exam. So now, as we studied our inverse of a function, and that is denoted by f inverse. Okay, here I'll take f as a function and its inverse is f inverse, and this f inverse will exist when a function is a 1, 1 and a onto. There are many functions and they don't have 1, 1, onto or both, and we can't talk about their inverse. If the function don't have a 1, 1, onto or both, in that case we can't talk about their inverse. So in this chapter we shall discuss about inverse of a trigonometric function. What exactly this is? Nothing but restrictions on domains and a range of a trigonometric functions that ensures existence of their inverse. Okay, and also we can observe in this chapter, that is their existence in a graphical representation. And also this inverse trigonometric function plays an important role in calculus. Calculus is nothing but we are going to make use of this inverse trigonometric function in an integration. And the last point, we can make use of this application, you can say that is inverse trigonometric function in your science and engineering, that you are going to come to know that you are further studies. Okay, now I'll just go with some basics, that is basic concepts. That is, if I take f as a function which is mapping from x to y, okay, I'll take x as a domain whereas y is a range. Hope you remembering these two concepts, domain and a range, we studied in our first PU. Okay, this function is mapping from domain to range, where I'll restrict it only a one function, that is function is, I'll take a sine. Now for this sin x, I'll take the domain which is a set of all real numbers, whereas the range is, which is closed interval minus 1, 1. Why this is a range means, you can observe that, so we have a sine values from 0 to 360 degree, where the values of a sine which lies between 1 and minus 1. So I can take the range of a sine is closed interval minus 1, 1. Whereas the domain you can take, it is a set of all real numbers. Now actually this sine is restricted to any interval. I take the interval which is minus 3 pi by 2 to minus pi by 2, or you can take minus pi by 2 to pi by 2, or you can take positive 3 pi by 2 to pi by 2. Now this sine function and its domain is nothing but set of all real numbers, and this sine function we can restrict it to any of the intervals, whereas its range is fixed, that is a minus 1, 1 closed interval it is. Okay, this is about the sine function, but we are discussing a inverse of a function, is nothing but, so as I said that if inverses exist, then the function should be a 1, 1 and a onto. So now I'll take this inverses exist on this domain to the range I can take any interval. Now I can say that this function inverse of a function is restricted to this domain and the range is any of the interval, now I can finally say that this domain is a 1 1 and this is range is a R2. Now I'll go with the range. It is of minus pi by 2 comma pi by 2. This is what a restricted range for a sine inverse, whereas the domain is minus 1 comma 1. So I said that, so minus 1 comma 1, why? Because all the sine values from 0 to 360 degree, those values will belongs to this minus 1 comma 1 closed interval. But the range is minus pi by 2 comma pi by 2. Why? Because this inverse of a function, that is a sine inverse, is onto in this interval. Hence I can say that this is a principal branch of a sine inverse. I can say that. Therefore, we can call it principal branch of sine inverse x. Therefore, the domain is minus 1 comma 1 and the range is minus pi by 2 to positive pi by 2 closed interval. Now we can look up with a graphical interpretation or graphical representation of sine inverse function. That is, here is, I took the sine x. This is a function where this function which is lies from x to y. I took x as a domain and y as a range, where x is nothing but, as I said that it is a domain and it is set of all real number and it is restricted to any interval, whereas the range is a closed interval minus 1 comma 1. Is it clear? So now I can go with a graphical interpretation, that is, I take this is a positive x-axis and this is a negative x-axis, hence I will just represent that as x dash. And this is a positive y-axis, this is a negative y-axis, that is y dash. Now y-axis, we have an interval minus 1 comma plus 1. I'll take it that as a positive one here and a negative one here. So which is 1 and minus 1. And this x is nothing but, which is the domain, I is nothing but, it is set of all real numbers. That means this sin x is restricted to any interval. I can write that as so here is a 0. This is a 0. If I take this as a pi, is 180. Here this is a pi. Next you can take this is a 2 pi. That is, both are negative because negative x-axis, and this is positive 2 pi. So in between, here you will get this is a 180, 0 to 180. In between this will be a 90. You can take it that is a pi by 2. And here is minus pi by 2. Okay. Next here is minus 3 pi by 2. And here is 3 pi by 2. Oh, this is clear. This is for the sine function, graphical representation. Now if I go with the sine inverse x, as I said, this is a inverse. Now this will be a y and this is mapping to the x. So y is here minus 1 comma 1 and this is mapping to the set of all real numbers. Then how exactly this graph means, you can take that is, I took this as a y and a x, but this first value will be, so this domain will be along x-axis only, whereas this values will be along y-axis only. So now I can represent this as x dash, y dash. So x axis we have here is -1 and this is +1, which is along x axis. Now along y axis it is set of all real numbers. You can restrict a sine inverse any of the intervals. So now if I take the same thing, you can write here is a positive pi and here is a negative pi. If I take this is a positive 2 pi and this is a negative 2 pi. So in between pi there will be a pi by 2 and in between minus pi this will be minus pi by 2. Now I can write the domain and the range of a sine inverse will be, the domain is -1, whereas the range, which is minus pi by 2 to pi by 2. So this is what the domain for the sine and this is what the range for the inverse of a sine, and this is the graphical representation of a sine function and this is a graphical representation of inverse of a sine. The same way you can refer a textbook or remaining 5 inverse trigonometric function, their domain and range and their graphical representation you can refer in a textbook. Sine inverse, domain and range. Okay, this is what the table for the sine, cos, tan, cot, secant and a cosecant, their domain and range. Okay, so sine inverse domain is -1, which is closed interval and the range is -92 plus 90, again that is a closed interval. And for a cos, this is easy to remember for 2 functions. Okay, so sine is a domain is a closed interval -1, the cos is also the same. Only thing is the range is, which is a closed interval 0 and 180 degree. Okay, next for a tan and a cot, these two are somewhat similar. Domain is the same, real number and a real number, whereas the range is same as the sine, but it is a open interval. Okay, open interval minus pi by 2 to pi by 2, and whereas a cot is the same as the cos range, but it is with the open interval. Is it clear? So remaining these two, secant inverse and a cosecant inverse, and for these two domain is, you need to subtract these two interval, that is -1, open interval with a real number. So in this real number you need to subtract this interval, then the remaining you can consider the domain for the secant and a cosecant. And the range is important, guys. So range is here 0, 180. In that you need to subtract with a 90, particularly for this secant inverse. Okay, for a secant inverse, if they ask a principal value, so there you will not get the value is pi by 2. Why? Because in this range we are going to subtract with this 90 degree. So from 0 to 180 you will not get the principal value for the secant is a 90. Why? Because we subtracted that. Next for a cosecant, that is minus pi by 2 to pi by 2. In between you will get the 0 degree, but particularly this cosecant inverse you will not get it. Why? Because in this closed interval we are going to subtract with a 0 degree. Okay, this is what the domain and the range for all the 6 inverse trigonometric functions, and you can expect, okay, 1 mark question from this. And based on these range, they'll ask a principal value of an inverse trigonometric function. That is again a 1 mark question. So before that, I can explain you one thing, that what is the difference between the inverse function and a trigonometric function. Trigonometric and inverse trigonometric function. So here I'll just take one example and I'll explain you. Sine, it is a trigonometric. Sine, inverse is an inverse trigonometric. So what is the difference of these two is nothing but Here we can find the value for the degree of this trigonometric function. So sine 30 we can write it as 1 by 2. Whereas in an inverse, it is a sine inverse of, they'll not give you the degree, directly they'll give you the value, sine inverse of 1 by 2. For this, you need to write the degree for that. That is 30 degree. This is what a small difference of a function and an inverse trigonometric function. So in a function, they'll mention the degree and you need to write the value for that. In an inverse trigonometric, they'll give you the value. For that, the corresponding radian or a degree you need to write. This is one difference. And one more is sine inverse of x. We can't write this as 1 divided by sine x. Don't confuse with these two. Okay? Inverse of trigonometric is a different. Inverse of any variable is a different. This is a function and we can't write this as 1 divided by sine x. Now, we can write this as sine x all inverse can be written as 1 divided by sine x. Okay. So now based on these range, we are going to solve the principal values for an inverse trigonometric function. So that is principal value. So principal value of an inverse trigonometric function can be defined as, it is a value which lies in range of principal branch. Then we can call it this as a principal value for an inverse trigonometric function. For example, if I take sine inverse of 1 by 2. What is the principal? Find the principal value of sine inverse of 1 by 2. So sine inverse of 1 by 2. So 1 by 2, in which radian, in which degree, the sine value is a 1 by 2, is nothing but 30. So 30 is nothing but, we can write it in a radian, that is pi by 6. So that value you need to check in the range of a sine. So sine inverse which is lies in minus pi by 2 to pi by 2. So is nothing but minus 90 degree to plus 90. There is an 30, right? Hence you can write the principal value of this inverse sine inverse function. You can write it as a pi by 6. So hence we can define the principal value of an inverse trigonometric function. It is a value which lies in the range of a principal branch. Okay, this value lies in the range of this principal value. Hence this is nothing but principal value of an inverse trigonometric function. Hope this is understood. Okay, thank you guys. So tomorrow we'll solve the principal value for an inverse trigonometric functions.